You guys are welcome to today's class. Of course, you already know we have the timetable. You know we're having physics today, and in today's class we shall be discussing position, distance, and displacement. We actually have a closed WhatsApp group where I tend to interact with all of my students. Okay, all of my students we chat, we interact, they tell me their areas of weakness, and I provide solution. I tell them the topics I would be, the subjects and the topics I will be posting. You know, I will be posting I'll be posting online, so they already have an awareness of this class. If you are not part of that group, please make sure you drop your name. Tell me, just comment, I want to be part, okay, so that I will get your contacts and add you to the group so you can be learning with us. I have over 40 students that are in the group and they are learning. All right, so you are not paying anything to be part of the group, so just tell me I want to be part. Okay, so just drop your name. And if you are online, you are watching, I know Nifemi, one of my amazing students is Nifemi. She's always very active. Nifemi, Akonde, Ayomide, Elijah, Isaac. If I not call your name, of course, I cannot remember everybody's name. Everybody watching now, I have over 40 students that will watch this video. I have not seen you physically. You have not seen me. All right, I cannot be mentioning everybody's name here. But if you are watching and I did not mention your name, just drop it down. Just say I am present. If your name is Favor, say Favor is present. All right, okay, let's head over to what we have. Please pay attention. Some of you message me personally, say, sir, you see, physics is so difficult. I don't understand it. No matter how I study it, I tend to not understand it. Actually, the thing is, there's no subject that is hard, there's no subject that is simple. It all depends on you. Okay, if you are serious with any particular subject, over time that subject becomes simple for you. Okay, if you give any subject time, what you need is to give it time. If you give any subject time, that subject becomes very simple for you. Okay, so please, as I'm teaching physics, and some of that have been complaining, oh, physics is very difficult, physics is this, physics is that, please pay attention. And the way some of you usually watch the video, follow this class, is probably maybe you are somewhere, you are outside, just pick your phone and just be listening to. You will not learn that way. I always tell you, go to your corner, your secret corner, your learning table, your learning space, get your note and your pen. Watch the video, see it as though you are in a classroom, like I am talking to you physically. Okay, if you have any question, I've always told you to message me personally. That's why it's very important that you are part of that WhatsApp group. You are active, because that is the only way you would have access to me. Okay, so position, distance, and displacement. In this video, I'll be explaining what position is. Okay, how you can actually locate the position of a point in a plane. Okay, and then I will be explaining what distance is and what displacement, and we'll be drawing a clear distinction between distance and displacement. Some persons don't know the difference between distance and displacement. If they say a body move from one point to another, from this point to another point, they say calculate the distance, calculate the displacement, you are confused. You don't know, because the both of them sound the same. Okay, first of all, one of the difference between this and this, that one is a scalar quantity, another one is a vector quantity. Please keep that at the back of your mind. Distance is a scalar quantity and displacement is a vector quantity. And if you are following this video now, I will define, I believe everybody you are SS1, beginning of SS1, they've already told you what scalar quantities are and what vector quantities are. Scalar quantities are quantities that have magnitude but no direction. So if we say distance is a scalar quantity, it means distance, we can only use a number. Magnitude simply means number. We can only assign a value to represent distance. It does not have direction. If I say a body travel 200 kilometer or meter, they not tell you the direction in which the boy travel. So they have only given you the distance the boy covered. We don't know if it's towards the west, east. No, we don't know. So this value, we cannot say it is displacement, it is distance, because it only tells you this 200 tells us the extent or the length of distance covered by this boy. So it's a scalar quantity, no direction, distance. But by the time we now say this boy traveled 200 meter eastward or westward or anywhere, so long a direction was assigned to this magnitude, this value, it becomes a vector quantity, because the definition of vector quantity is that they are quantities that have both magnitude, and we talk about magnitude, we are referring to numerical values, that is a number, a value, both magnitude and direction. And displacement is an example of a vector quantity. That is one of the difference between distance and displacement. Why this one has direction, this one does not have direction. But remember, there's something similar between them. They have the same units. Okay, the only difference is that one has direction, the other one does not have direction. And in calculating for displacement, calculating for displacement and distance, there's also a difference. Okay, please pay. I've already started my teaching. Remember, I started from here. I've not talked about what position. I want people should know what position is. Before I continue with distance and displacement, let me talk about this position. We talk about the position of a body. I'm simply talking about the point where that body can be located. Okay. Talking about the position of a body, it is the point where the body can be located in space. Okay, the point where a body can be located in space, that is position. And we have a way of locating the position of an object in space. We do that by drawing a straight line. Let's say this is the point. You draw a straight line. Now listen, for those that know how to plot graph, you have understanding of what I'm saying now. Now listen. If you want to locate the position of a body on a plane, and look at this, you draw a straight line like this, let the lines intersect, and their point of intersection, that's what they call the origin. This point, you call it the origin. You draw two lines, vertical and then horizontal. The two lines must be perpendicular to each other. And when we say lines are perpendicular to each other, it means that they form angle 90 here like this, perpendicular lines, like just cross. It intersects and it forms angle 90 degree. That's meant by perpendicular. So vertical and what? Horizontal. This horizontal line, that's what we call the x-axis. And the vertical line is called the y-axis. Let's say we want to locate the position of this point P. We don't know. We want to locate this point P. A point here. There's a point we want to locate. Now listen attentively. Listen attentively. To locate this point, first of all, you draw these lines. Okay. Then you will now look for the coordinate of this point. In other words, the distance of this point from O along the y-axis and the distance of this point from O along the x-axis. That will give you the coordinates of this point P. The distance of this point from O along the y-axis, along the x-axis, and the distance of this point from O along the y-axis. So let's assume if you trace this point from this point downward, if you trace it downward, please pay attention. If you trace it downward, remember this is along the x-axis. You call this x1. Let's just call it x1. Right? And if you trace this one up, so that it would touch this y-axis, we call this one y1. So you can see that the distance of point O from O, I mean the distance of point P from the origin, the distance of this from the origin along the x-axis, is x1. It is the distance of this point. Let's assume this point was here. The distance of this point P, let's assume this P was here. This distance of P along the x-axis from O from this origin, it's what? X1. And the distance of P from O along the y-axis is what? Y1. So if I am representing the coordinates of this point, you will see something like this. Please, you write that of x1 first. That is the distance of O from P along the x-axis, comma. Remember, it is x1 and what? Y1. That is the distance of P from O along the y-axis, which is y1. Remember, I wrote that of x first before y. Please take note of it. Take note of it. Take note of it. Now, the x-axis, that is what they call the abscissa, x coordinates or abscissa. Why the y-axis is known as the ordinate. Okay, please take note. This is how you represent the position of a point in space, or the position of a point on a plane. Okay, you look for the coordinate of that point along the x-axis. which is this, and that of the point along the y-axis. So it means if we have something like this, if you have a coordinate like this, 2 and then 5, if you have to draw the graph of this, first of all, a straight line. This is point O, origin. Remember, this first number talks about the value, the distance of the point from O along the x-axis. Don't forget this first number here, along the x-axis. So it means I will have to trace this to this point. Let's assume this is my 2 along the x-axis. Okay, let's assume this is the point. So if I trace it here, it will give me 5 here. That is the distance of the same point along the y-axis. X, Y. That is it. So if you have these two, if you have this graph, let's say A. Let's say this is minus 3 and this is 5. If you have to write the coordinate of this point, it will now be what? Point A has these coordinates. Remember, you write that of x. Remember, x now is now minus 3, comma, and 5 is what? I mean, that of y is what? 5. So we have succeeded in writing the coordinate of this point. That is for position. Leave position. Let's move to distance and displacement. Let's go back to distance and displacement. So for those that have paid attention from the beginning of this class, I've started explaining the difference between distance and displacement. I told you that distance is a scalar quantity. Distance is a scalar quantity. And displacement is a vector. That is number one difference you should first of all note between distance and displacement. Remember, they both have the same unit, which is Newton and Newton. Okay, now let us assume, now listen, pay attention, we are going somewhere. If they tell you that a body travel from point A to point B, when it gets to point B, change direction to another point C. Remember, from point A covering a distance of 2 meters, from B to C covering a distance of 3 meters, and from C, the body now left point C to another point again, point D, covering a distance of 2 meters again. Now, if the question says you should calculate the distance of this body as covered, all you need to do is to add this distance plus this distance plus this distance. So it means that total distance covered equals to 2 plus 3 plus 2, which is equals to what? If you add everything, it gives you 7 meters. That is the distance covered, no direction. Okay, now if they now ask you to calculate the displacement, please, displacement is not the same way you calculate for distance, so I beg you in the name of God. Now, displacement is simply the shortest distance between displacement of this body. Now is simply the shortest distance between point A and B. And what is the shortest distance? This is not the shortest distance. This is not the shortest distance. This is not, the shortest distance is to draw a straight line that connects from A to D. That is the distance between the starting point where the body started its motion or its movement, where the body started from and where the body ended its movement. The distance between those 2 points, that is the displacement. So if you can calculate the length of this line, that will give you the displacement of that body. Let us take another example so that you understand what I'm saying. Now listen, if they say a body travel due, now listen, write this question now. Example, a body travel, should I write now? Please, I'm managing my space. Okay, you should take, I'll say you should have a writing material. So please write, I'm managing my space. If I use the question to cover this, but I won't have space to solve. Don't worry, I'm still trusting God that I will have a better board. Okay, now a body travels 4 meters due north and 3 meters due west. What? Calculate the distance and the displacement of that body. Calculate the distance and the displacement of that body. The body travels 4 meters due north. It changed its course and traveled 3 meters due west. Calculate the distance and the displacement of the body. Okay, first of all, let us use diagram to analyze the question. A body travels 4 meters due north. Now look at it. Joy of cardinal point. This is, remember, this is your north, this is your south, this is your west, and this is your east. They say due north. If they say due north, that means from the body just travel up, like up. Just follow the northern direction. Just go due north. That's what we mean by due north. All right. Body traveled 4 meter. This is 4 meter. This body changed course and therefore travel. That is now deviated its direction again. It started traveling what? 3 meter due east. So I mean due west. West is this side, this direction here. So it means it will travel like this. This is 3 meter due west. So the question says we should calculate A, distance. Travel like this and like this. And B, displacement. Now look at it here. They said we should calculate distance. How do you calculate distance? Distance is just to sum. It traveled from this point to this point. What distance did it cover from here to here? 4. And from here, it now travel to this place. What distance does it cover? So total distance is to add this and this. So distance, solution, our distance is equals to 4 meter plus 3 meter. That will give us 7 meters. That is the total distance covered by that body. You see, physics is very simple. It's just that if you don't understand, that's why you take it is hard. See, just imagine this question is just to add this and this. Total distance covered. But if they say displacement, remember I told you that displacement is simply the shortest distance between the starting point and the end point. This was where the body started from. This is the end point of the movement. So shortest distance is that straight line that connects the starting point and the end point. So if we have to calculate this is our displacement now. This line, the length of this line is our displacement. So how do we calculate the length of this line? If you picture this diagram very well, you are seeing something like this. And this is 3 meter and this is 4 meter. You are seeing something like this. And if you pay attention, if you have been listening in your class in school, your school SS1, in fact J2 self, they have taught you something like this before on Pythagoras theorem. So Pythagoras theorem now will help us get the length of this side. Let's assume the length of this side is x. Okay, so Pythagoras theorem is what would help us, what would assist us in getting the length of this side, which is x. And Pythagoras theorem simply states that in a right angle triangle, the square of the hypotenuse side. And some persons don't understand what a right angle triangle is. A right angle triangle is that type of triangle that has one of its angle to be 90 degrees. Please, this sign means 90 degrees. Anytime you have a triangle that has one angle to be 90 degrees, that triangle is a right angle triangle. Okay, I repeat again, anytime you have a triangle that has one of its angle to be 90 degrees, that triangle is a right angle triangle. So we have this is a right angle triangle. All right, and anytime you have a right angle triangle, Pythagoras theorem is applicable to all right angle triangles. When you are looking for the side, Pythagoras theorem gives us the relationship between the sides of a right angle triangle. Please take note. I'm also teaching you mathematics here now, because that's why it's very hard for you to understand physics when you don't know mathematics. Okay, so whether or not you are doing mathematics or not, whether or not you'll be doing mathematics, because some of you now is medicine and surgery you want to study, and you will not write mathematics in JAMB. Okay, and because of that, many people don't understand. They don't attend maths class. I advise those students that want to do those medical courses to always attend mathematics class, because you will do, if you are not doing mathematics, you will do physics, and if you don't understand mathematics, physics, you will struggle with it. Yes, you will struggle with it. So pay attention. Anytime I call for mathematics, I make sure whether or not you will write it in JAM, you will pay attention. You must attend. I beg you in the name of God. So this is a right angle triangle, and that theorem says that in a right angle triangle, the square of the hypotenuse side is equal to the sum of the squares of the other two sides. So the square of the hypotenuse, this is the hypotenuse side. So our s square of the hypotenuse side, that was the reason why I put s square here, is equal to the sum of the square. Sum means addition. Sum of the squares, 3 square plus 4 square. Sum of the squares of the other two sides. So how do you solve this? S square is equal to what? 3 square is what? 9. That is 3 times 3. 3 square is not 3 times 2. I beg you in the name of God. Some person will still go and put 3 times 2. 6. It's not 6. 3 times 2 is 3 square is not 3 times 2. 3 square means 3 times 3. Assuming it was 3 cubed, it will be 3 times 3 times 3. I don't know if you understand what I'm saying here. I beg. I'm saying this because out of this, I've seen many students, they'll tell you 3 square is 3 times 2. I've explained this to many, many times. Now look at this. 3 raised to power 2 is 9, I beg you, which is 3 times 3 plus 4 raised to power 2 is not 4 times 2. It is 16. 4 raised to power 2 is 4 times 4, which is 16. So you have this to be s squared equals to, if you add these two together, it gives you what? To give you something like 25. If I'm not mistaken, yes, of course, it should give you 25. So if it is 25, what do you do now? Remember, we are looking for the value of x, not s squared. All right. So we have to eliminate this square from here. And now you do that is to square root both sides of the equation. If you square root both sides, this one will cancel this. So our x is equals to what? Square root of 5 is, square root of 25 is 5. So our x is equals to 5 meters. X is equals to 5 meters. That is the displacement. We have calculated the displacement now because we said that displacement is simply the distance between this point and this point. And the value of this point from this point, the value of this length connecting these 2 points is what? 5 meter. So our distance is 7 meter and our displacement is what? 5 meter. Please, to prove that you understand what if you don't understand it, then watch this video over and over and over again till this thing you understand it. Is very simple. It's not hard. Okay, if you don't understand it, that means you don't really pay attention. So I would advise you to watch it over and over again, because of course you will solve your own for me. Now, right, solve this one for me and drop the answer at the comment section. Solve this for me. Solve. Let me dictate the question. A body or a boy. Oh, let me use Nifemi's name. Let me use Nifemi because I know that Nifemi is online now. She's watching this video, so I want to use Nifemi's name. Meanwhile, if you are very active, this is why Nifemi's name is always alike. It's always because she's very active. When I see people that are very active, of course, your name will never leave my lip. It's the same thing with Akonde. The same thing with this guy, Kayode. Several amazing persons like that. Okay, so please make sure you're always active. And okay, if Nifemi walks, let me use walks 8 meter eastward. She then changes a direction and walk 6 meter. Let me not use 6 and walk 6 meter in the southern direction. Calculate a total distance and B a displacement. Okay, please solve this. Drop your answer at the comment section. When I mean drop it at the comment section, I mean drop it at the comment section. It's very important. Okay,